Most memory research focuses on intentional or voluntary retrieval. For instance, in the talk you just heard, participants studied two lists of words and were asked to intentionally recall the words from one or both of those lists. However, work by Dorthe Berntsen and colleagues estimates that about half of the episodic memories we experience in everyday life are involuntary. That is, they come to mind without intention, and these memories can be triggered by internal thoughts or external stimuli and are distinct from implicit memory in that they involve conscious recollection. For instance, I was reading a book to my son the other day, and it included a picture of Big Ben. I asked him if he knew what it was, and he said yes. And it brought to mind automatically this clear memory of a chaotic day trip that we took to London back when he was a baby and I was a postdoc at Cambridge. Several details of the event came flooding back to me, a true episodic memory. But I didn't search for this memory, it just came to mind when I saw the picture of Big Ben. And while a long line of work shows that voluntary episodic memory is impaired with age, recent work suggests that involuntary retrieval is relatively preserved. So for instance, diary studies have shown that older adults recall a similar number of involuntary memories as young people throughout the day, but they recall fewer voluntary memories. Similarly, a recent lab study in which participants watched a sort of virtual reality movie, they found that there were no age differences in the number of reports of involuntary memories, but older adults were slower and reported fewer voluntary memories. And this might be because involuntary retrieval places fewer demands on top-down attentional control. For instance, in an fMRI study by Hall and colleagues, they had participants engage in voluntary versus involuntary retrieval in the MRI scanner, and they found that voluntary retrieval alone is associated with activation in the dorsolateral prefrontal cortex, a region critical for top-down control, whereas both types of memory activated more posterior memory regions, such as the medial temporal lobes or the posterior midline, including the precuneus, because these were visual memories that were coming to mind. So this suggests that the phenomenological experience of both types of retrieval is the same. It's just that voluntary retrieval involves this additional sort of top-down controlled search. So we know that voluntary memory declines with age, while involuntary memory is relatively preserved, but we don't know why this is the case at a neural level. And so the current study, which was led by my graduate student, Sarah Henderson, was designed to test what the neural underpinnings of voluntary and involuntary memory are and how they differ between older and younger adults. And for this purpose, we adapted the paradigm of Hall and colleagues for use with EEG. So this study involved participants coming into the lab for 2 different days. The first day was the encoding day. Retrieval happened on the second day. And in the encoding session, they first heard a series of paired pictures and sounds, and they had to learn environmental sounds, and they had to learn that these went together. So for instance, they might see this image of the babies and hear something like this. And they had to create a sentence that linked those 2 stimuli together. And they got 3 opportunities to encode these pairs. And importantly, they're semantically related to each other, so these pairs are quite easy to learn. They also heard a series of unpaired sounds. These again are environmental sounds, and of course they were counterbalanced across participants between the 2 conditions. And for these, they just had to rate the uniqueness of the sounds, but they weren't paired with an image. Now, importantly, participants were led to believe that this was actually a study about sound localization, and that we were interested in, if they paired a sound with an image, how is this going to affect their ability to localize that sound in space? And this cover story was necessary in order for the people in the involuntary retrieval group to not know that their memory was being tested later at retrieval. So it was a between subjects design. We had people either engage in the voluntary retrieval or the involuntary retrieval group. So participants came back to the lab 2 days later. They first got a chance to re-encode all of the sounds, both the paired and the unpaired sounds. And then we set up the EEG equipment, and now they're going to take part in this supposed sound localization task. People in the involuntary group were simply deciding which side, which ear the sound was louder in, whereas those in the voluntary retrieval group were told they were deciding which side the sound was louder in, but they were also asked to try to bring the associated picture to mind. Now, this is important because we assume, because these are really well-learned pairs, that those in the involuntary retrieval group will also have those images come to mind on some trials. And that's, we're going to be able to get at that by looking at their EEG activity when they hear these sounds. We had young and old take part in these two different conditions. Again, it was between subjects. And then afterwards, they had the EEG equipment removed, and we had them perform this sort of retrospective memory report. We didn't want to ask about memory online during the sound localization task in case it made involuntary people start trying to remember the pictures. So now we played them all the sounds again, and they told us for which of those sounds during that sound localization task did they have a conscious recollection of the image that was associated with the sounds. So our predictions for the behavioral data, first of all, we thought the age differences in retrospective memory reports should be minimal in the involuntary condition, but we may see fewer reports of memories in the voluntary condition for older adults, in line with previous work. But we also looked at their reaction times during the sound localization task itself, because this provides a sort of online or implicit measure of retrieval. And we might expect people's response times to those sounds, just how fast they decide which side is louder on, to be slower for the paired than the unpaired sounds, reflecting a sort of interference effect from having that picture come to mind. It might slow them down in their response to the sounds. And we also might see people respond more slowly during voluntary than involuntary retrieval because of interference from the intention to retrieve, because those people are sort of in a dual task scenario. So turning to the results, first of all, looking at the retrospective memory reports for our involuntary group and our voluntary group, we see the expected, age-related decline in the number of reported memories for older adults. They say in the voluntary group that they had fewer memories retrospectively during the sound localization task. But surprisingly, we also see an age difference in the involuntary condition, in that older adults, again, are reporting that they had fewer memories during the sound localization task. It is important to note, as I keep saying, these were retrospective reports. And older adults might be less accurate in reporting. This is basically a memory of a memory. Previous work has shown age differences in metacognition, so it could be that that's why we're seeing this age difference here. If we look at the reaction time data that was collected online during the sound localization task, we are seeing a main effect of pair type, such that participants are slower to respond to the paired than the unpaired sounds during that sound localization task, possibly because reactivating the associated image is sort of interfering with their response to the sound. And importantly, this effect was significant in the older adult group alone. So it's not being driven by the young people here. And we also see a main effect of voluntariness. And this is due to participants in the voluntary retrieval group responding more slowly than those in the involuntary group, suggesting that having this dual task sort of scenario where you're also trying to bring the picture to mind is slowing down how quickly they're responding on the sound localization task. Turning to the EEG data, we were interested in event-related alpha desynchrony instead of ERPs in this case, because it tends to be more robust to variability in the timing across trials, which was important in this case because we're using these sort of strange environmental sounds. You can think of alpha oscillations, shown here in the 8 to 12 hertz range, as sort of the default activity of the brain. And so when you see desynchrony or their noctative synchrony, it tends to reflect activation of that population of neurons that's generating those oscillations normally. So it reflects processing or activation within that population of neurons. When seen over frontal regions, it's been associated with top-down attentional control. And when seen over occipital regions, it reflects reactivation of visual memories in some cases. So we were interested in primarily in these two regions of interest, both a frontal region and an occipital cluster. Predictions for the EEG data was that we'd see greater frontal and occipital alpha desynchrony during voluntary retrieval than involuntary retrieval across both age groups, reflecting the increased attentional demands of voluntary retrieval. But in terms of aging, we may see greater recruitment of top-down control regions during involuntary retrieval in older adults, which would be in line with previous work showing greater frontal recruitment in older adults, even at lower levels of demand. And in terms of a memory effect, we expect to see greater alpha desynchrony in response to paired than the unpaired sounds across all conditions, reflecting possibly the visual reactivation of those scenes that were associated with the pictures. And that's only possible in the paired condition, not in the unpaired condition. So for the voluntariness effects, this is the age by voluntariness interaction, and we did see a significant age by voluntariness interaction. And this was due to young people showing greater alphas here, alpha desynchrony during voluntary retrieval relative to involuntary retrieval. And this is just the difference plot. And you see the black regions indicate significant portions of time after cluster correction. So young people are showing greater alpha desynchrony, like we expected, during voluntary retrieval, whereas older adults don't actually show any difference in their alpha desynchrony between voluntary and involuntary retrieval. And that's what's driving this age by voluntariness interaction. It could, well, I'll get into that in a moment. Turning to the memory effects, we actually don't see any difference in desynchrony for the young between the paired and the unpaired sounds. None of the difference here reach significance. Whereas for older adults, we do see the expected greater alpha desynchrony for paired than the unpaired sounds. And even after correction, we see that there's a significant difference around 1.5 to 2 seconds post-stimulus onset, suggesting that older adults may be reactivating the image for the paired sounds. So some takeaway conclusions. First of all, whether age differences in involuntary memory are observed seem to depend on how that memory is tested. When we use the retrospective memory reports, we do see an age-related decline even in involuntary retrieval. But when we use the online measure of reaction times, it seemed like older adults were retrieving the associated pictures in both conditions. Alpha desynchrony, in this case, related to memory reactivation in older adults. We're not quite sure why we didn't find this in young people, as it's been shown before, but we have some ideas as to why that is the case, which I can get into later if there's any questions. While there were no age differences in desynchrony during voluntary retrieval, we found that older adults showed greater alpha desynchrony than young people during involuntary retrieval. And while I just showed the frontal ROI in the results, this was true for both the frontal and the occipital ROIs. But this is in line with previous demonstrations of greater recruitment of attentional resources, even at lower level of demand, such as the view put forward in Crunch. That is, older adults max out their top-down attentional control, even at low levels of demand. Although I slightly suspect that this might have been due to the nature of the paradigm we used here, and then if we could come up with a more naturalistic way of testing involuntary memory in older adults, we might not see this sort of difference. So that's where we're gonna go with future work. So I just wanted to thank you for your attention and thank all of our collaborators at Brock, all the people who helped make this paradigm possible, this study possible, and also to all of our funding agencies. Thanks for listening.